What solid carbon products does is we convert CO2 into industrial carbons. Right now, industrial carbons, as you so correctly described, are dominantly made from hydrocarbons, from fossil sources. The sheer act of either doing a controlled combustion of that fossil source or a distillation means there's a great deal of CO2 emitted. In the case of carbon black, which is what is used to reinforce the rubber in tires, there are 2.5 to 3 tons of CO2 emitted for every ton of carbon black produced. The numbers are dramatically higher for every ton of synthetic graphite produced, for every ton of coke for steel making produced. So what we have as a globe is a historical manufacturing method to produce industrial carbons from fossil carbons with the large CO2 associated emissions. That's put us into an interesting position where essential materials are emitting CO2. Wouldn't it be interesting if we could use the CO2 emissions from other essential industries to make those industrial carbons, and thereby doing a significant re-engineering of the carbon production industry by sourcing that carbon from CO2 instead of from hydrocarbons? That is the premise that I would like to discuss today. With your permission, I'm going to share my screen.
Sure, please go ahead.
Very good. One of you can see this? Just one person say yes, please. Very good. Thank you. Solid Carbon Products is a small company. We have developed a technology that allows us to take CO2 and hydrogen or natural gas and convert it into solid carbon materials and distilled water. There is a breadth of carbon produced for our global industries. We use carbon nanofibers in order to reinforce carbon composites. We use high purity carbon in the electrodes for metal making and also for lithium-ion batteries. The next largest use is carbon black, where over 14 million tons of carbon black are produced annually. And then there is coke for steel refining. Right now, we are working with Goodyear as an example of a user of carbon black. That will allow the tire industry to significantly reduce their carbon footprint. When we talk about re-engineering, right now, when you look at the globe and how CO2 is produced, emitted, and how carbon is used, on the left-hand side, you're looking at CO2 producers. Those are ethanol producers which produce a high purity CO2 stream that can be used as a feedstock for our process. Wouldn't it be valuable if CO2 producers could repurpose their CO2 as a feedstock to produce solid carbon? Right now, carbon producers, let's use carbon black as an example, are using hydrocarbons. They are doing a controlled combustion to produce a range of carbon blacks, dominantly 70% for the tire industry, and that has a significant CO2 footprint. That doesn't have to be the case. Carbon black producers over time could migrate to using CO2 as the carbon source. And when you read their sustainability reports, that is the direction that they are wanting to go. Burla Carbon, for example, when you read their sustainability report, they are actively looking for technologies that will shift the source of carbon from a fossil carbon to a CO2 source. And then you look at the carbon users. The carbon users globally are tires dominantly, and then all of the additional paints and plastics and polymers that you see that support our industry. Everything that you see around you that has black in it, that black was produced almost exclusively by burning a heavy fraction of oil. When you look at the column to the far left and you look at the column to the far right, that is where we should be able to take CO2 utilization. Let us take CO2 from the emission point sources. Let us take CO2 out of the atmosphere. Let us use it as the carbon source. From SCP's perspective, all we need is industrial grade CO2. So companies such as Mitsubishi Heavy Industry, Clean Carbon, there are many companies which are now so effectively addressing CO2 capture and scrubbing. So from SCP's perspective, we need industrial grade CO2 that could come either from the output of an ethanol or an ammonia facility, from natural gas extraction, or by using one of the currently fully commercialized carbon capture technologies, or working with some of the emerging carbon capture technologies. What is our mass balance? How much CO2 does the noise process put away? We take 3.7 tons of CO2, 0.3 tons of hydrogen, and produce 1 ton of carbon solid material and 3 tons of distilled water. In the United States, we have already received federal approval to release that water to the surface waters of the United States. It can be repurposed for industrial or agricultural use. It is simply distilled water. Our process offers a net sequestration. Our carbon can also be used as the carbon for blast furnace operations for steel making. It has comparable BTU content. Our water could coexist with the water needs of a steel refinery. So there are many ways for the noise process to support existing high carbon intensity industries and lower their footprint. We are operating at TRL level 6. We are operating a pilot production unit. It is robust, it is steady operation. We are tremendously pleased. It is under full computer operation. This is a high-level PFD of our system. You can see that it is 2 gases coming in, hydrogen and CO2, coming into a dilute phase fluidized bed reactor with an iron catalyst, a very low-cost catalyst. The gases leave the reactor with the carbon and moisture of reaction entrained in it. The carbon is then pulled out, the water is condensed out, and this closed loop, no emissions system operates in a continuous flow. What is our next step? Where are we going from here? We need to deploy this technology globally. We have been working with entities in India, in Japan, in Europe. We are delighted to be making solid progress. There is strong industry interest. Our next step is to build a commercial demonstration unit that allows companies to look at this technology at commercial scale and validate for themselves. We already have the product going through validation with companies such as Goodyear. I think you all know who Goodyear tires are. In a recent New York Times article, Goodyear stood next to us and spoke about the sustainable tire line that they want to get out into the market. Can this be done profitably? Carbon black as a material is not a particularly high value material. However, our process at commercial scale is lower cost, starts with a higher purity feedstock, a lower cost feedstock, and at commercial scale of operation, our engineering projections are showing that our cost per ton is less than the current cost per ton of operation of a traditional fossil fuel-based carbon black manufacturing. But what about at the early scale of operation? What about at the 25 or 50 ton a month scale of operation? How can we be profitable at that scale? That is where being able to convert the carbon that comes out of the noise process into graphite materials is going to ensure that that early stage of commercialization is fully profitable. The graphite industry is under considerable pressure because of the emerging of battery-driven mobility. The electric vehicle market is changing the volume of battery needed to serve where humankind is going. Solid graphite structures are where the electrodes for electric arc furnaces need to go, as the world is pivoting from blast furnace operations to electric arc furnaces with its reduced cost and reduced CO₂ footprint. There is a pending global scarcity on the petroleum needle coke necessary to produce synthetic graphite. Synthetic graphite is needed for solid graphite and lithium-ion batteries. The noise process, solid carbon products, provides the base carbon that can then be graphitized into these two essential materials. So how are we going to do this? Solid Carbon Products is committed to global propagation of this technology. We are a technology licensing company. We have a mission. Any of you in the audience that are interested in licensing this technology, whether you are a CO₂ emitter or a carbon user or a current carbon producer, we are looking for global partnerships. We want to upgrade the technology underlying the global carbon industry. We would welcome your participation.